Of course, not all triangles are right-angled, so we need to create some rules to allow us to work with non-right-angled triangles. The sine rule is the first of these rules. So here is our triangle, which is not right-angled. But at this stage, theoretically, all we know about is right-angled triangles. So let's create things we know about right-angled triangles. I'll drop a perpendicular down, call it h, seeing it's the perpendicular height of that triangle. And what can we then do? In one of those right-angled triangles, we can say h on c is the sine of b. So h is c sine b. But of course, I could look at the other right-angled triangle and say h on b is sine c. It now becomes a bit like parametrics. It's like we've created parametric equations. And how do we bring it back to the equation? We eliminate the parameter. Let's eliminate h. C sine b will be b sine c. Playing around with that, and we get something we're familiar with. What we see is the sine rule. Of course, I just chose those two angles. I could have just as easily played around with the angle A, and I'd get the same thing. So A over sine A is B over sine B is equal to C over sine C, which is the sine rule, sort of. But I'll come to that later. Let's quickly just do an example of it. So here's a typical sort of question. We know two angles. We've got one on the side. We want to find the other side. So in this case, h on sine h is q on sine q. Substitute in our numbers. Make h the subject. Bit of calculator work. We come up with our answer. Now generally when I'm giving an answer to something like this, if I am going to use an approximation and they don't tell me how many to use, I'll go and try and match the question. Now in this question it looks like the side's been given to me to 1 decimal place, so I've given my answer to 1 decimal place. Of course we could be asked to find an angle. We just sort of reverse it round. It's just a lot easier to make what it is I'm trying to find the numerator rather than the denominator. I mean, you don't have to, it's trivial I suppose, but that's just how I tend to do it. So in this case I'll write it as sine y on y is sine z on z. Substitute in, make sine the subject, because I need to make that the subject before I can find y, and I'll get our answer. 46 degrees 58. Or is it? See, this is the unfortunate thing with the sine rule. Because we're talking about triangles, and angles in triangles can either be acute or obtuse. But the unfortunate thing with sine is they both give us positive numbers. So that question we just did, this is a positive number. And of course the calculator assumes you're talking about the acute angle. And in this case it is the acute angle. But sometimes we just need to quickly check. Does it make sense? And keep in mind these sorts of things. We know the angle sum of a triangle is 180. And we also know the largest angle will always be opposite the largest side. And in fact, the smallest will be opposite the smallest side, and so on. So in that last question that I just did, I knew it had to be the acute angle because I've already got an obtuse angle in there, and I can't have two obtuse angles in one triangle. So really, that was the only possibility. But sometimes it might not be the acute angle that it's given to us, so we just got to watch out for that. And I also said that's the sine rule, sort of. Not sure if you're aware of this or not. If you were to draw a circle around that triangle, which we call the circumcircle, that is the sine rule. It actually turns out that that ratio will be equal to the length of the diameter of the circumcircle. So that sort of completes the sine rule. How about area of a triangle then? Once again, let's drop that perpendicular down. Now we know the area of a triangle is half base times height. We know that. But again, let's play around with this a bit. So I could say h on b is sine c. So h is b sine c. And there's the area. So actually we don't need to know the perpendicular height. We could do it this way, half AB sine C. Again, that was just because I was using the angle C. I could have done it with any of the angles. Basically, it's two sides and the included angle. If we've got that, we can find the area of the triangle. Now, a quick little example there. I've got two sides, I've got the included angle. So yes, I can use that formula, find the area. And this time I did it at 2 decimal places. Again, I'm just matching what the question had. All right. There's a quick recap of our sine rule.